Okay, here we go. Hello, everybody. This is the Mining Software Repositories 5 session. My name is Sonia Hajduk, and I will be chairing this session. And we have 6 exciting presentations today. And again, the order in which we will have those presentations is the order that you can see in the program on researchers. So with that being said, let me introduce the first talk today. So our first speaker is Maxime Lamotte, and he will be talking to us about assisting example-based API misuse detection via complementary artificial examples. Maxime, the stage is yours.
All right. Thank you, Sonia. So, as was just mentioned, my name is Maxime Lamotte. I'm an assistant professor at Polytechnique Montreal, and today I'll be talking about assisting example-based API misuse detection by using complementary artificial examples. So, first of all, APIs suffer from some pitfalls. There are quite a few pitfalls, but the one I want to concentrate on today is that by design, users are decoupled from API development. So this is actually a good thing. This is done on purpose. It's by design. People who want to create new functionality, who have domain expertise, will produce code, and then to abstract away the complications of that code, they will create an interface to allow people to use what they've produced without necessarily knowing the underlying nitty-gritty details. So that will allow users to use certain tools, certain software without necessarily knowing the details. But the downside is that, of course, because we don't necessarily know the details of how something works, we may misunderstand how it's meant to work and therefore potentially misuse it. Now, to save that, misuse detection approaches do exist, so there are many of them. Most of them are static misuse detection approaches, but there are also approaches that use specifications to attempt to do the same thing. The problem is that most of these approaches, on average, have a low precision. We're talking about 30 to 40% precision. Now, this is kind of good because we can actually help detect these defects, but the problem is that it makes it difficult for users of these approaches to distinguish whether what they're getting as feedback is actually a misuse or is a false detection. So here in this research, what we try to do is understand where misuse detection make mistakes. Particularly, we look at static API misuse detection approaches, and we started with the state of the art at the time, which was MuDetect. So we found that MuDetect, on average, has about 28% false positives. How we did that was by using the approach on real projects and manually sifting through a portion of the data. So what we want to do with that data is determine whether we can find some recurring patterns and determine if we can help. So we start with the approach, MuDetect. We detect some potential API misuses in projects. We manually label some of them. In some cases, we weren't sure if they were misuses or not. We're not domain experts on those 818 projects, so we set those aside. In many cases, they were actually detecting true misuses, so that's good. That's the tool working properly. But in 108 cases, we found that the tool was thought it was detecting misuses of APIs, but it was actually detecting alternate correct usages. And so we want to be able to help those alternate correct usages not be detected as such. So we manually identified 5 transformation patterns where we can apply these transformation patterns to API usage examples that have been mined and create modified API usage examples based on our automatic transformation patterns, which can then be fed back into API misuse detectors to improve their overall detection. So this can be automated. But we want to determine if we do use these artificial examples, are we actually helping? Are we reducing the false positives from API misuse detection? So to test that, we start with MuBench, which is a misuse detection benchmark with API usage examples and 50 open source projects that had never been seen before by the approach or by us in our training set. We applied our transformation patterns to these examples, generating modified API usage examples, which we then fed into the exact same detector. And we manually compare the results. What we find is that we actually do help detect some properly detect misuses. So for our, then we check, well, are we actually removing some positives from the detection? Are we hindering the detection of false positives? To test that, we look at an upper bound recall experiment, which exists in NewBench, and we do the same thing. We apply our transformation patterns. We apply both of our examples, modified and original, to the recall upper bound experiment, and we again manually compare the results. And what we find is that our complementary artificial examples actually have no effect on the recall of API misuse detectors. So we're helping properly detect examples, we're not hindering. So that's the overall approach. If you want more details, please see the paper. And if you have any questions, please feel free to ask me after the talk. Thank you very much.
Thank you, Maxime. Perfect timing. And I just want to remind everybody while we're getting ready for the next talk, Enrico, you can already share your screen, that basically we're having 5-minute presentations, one after the other. And at the end, we will have the question and answer session. And you can type questions in the chat at any time or at the end during the Q&A session, or you can unmute yourself at that time when we're done with the presentations to ask the speakers questions. And when you do so, just mention which speaker the question is for. Okay, so now we're ready to move on to our second presentation, and that will be by Enrico Fregnan, and he will be talking to us about what happens in code reviews, an investigation on automatically classifying review changes. Go ahead, Enrico.
Thank you for the introduction. So in this paper, we focus on code review, which is a fundamental part of the software development process. So code review has 3 main benefits. It helps developers to assess the quality of the code and find defects in it, but also it allows developers to transfer knowledge between, for instance, a junior and a senior developer. However, previous studies showed the existence of a strong mismatch between what developers and managers think to obtain as outcomes of the code review process, such as, for instance, catching important defects early, against what the real outcomes of the code review process are. So only few low-level defects are coded. So this shows that our knowledge on the real outcomes of code review is still limited. For this reason, in this paper, we investigate code review changes. So what is a code review change? A code review change is a change in the code between different round of revision. For instance, here you can see that in the old patch set, a reviewer asked the author to remove the try and catch statements. Then the author performed the change and uploaded a new patch set. So our goal is to look into these review changes and classify them. To answer the following question, what kind of defects I really found during the code review process? So this question was already tackled in previous work, but unfortunately, they had to do so manually, which is a major drawback in terms of scalability of this approach. So in this paper, our goal is to investigate the feasibility of devising an automatic way to classify review changes. So we started our investigation by randomly selected reviews from 3 open source projects, Android, JGit, and Java client, and manually classifying them. So we assigned to each change in this review a category. So a change could be an evolvability or maintainability change, or a functional one. And we also assigned a group. So a change could be a documentation change, visual representation change, if it impacted how the code looks like, a structural one, or again, a functional one. So this process led to the creation of a data set of 2,640 classified changes that we used to train and test our model. So we investigated 30 features. We tried 3 different machine learning approaches. And finally, we investigated the performance of our approaches in 2 different classification scenarios at category and at group level. So here you can see the performance of our approach at category level. So the best performing approach was random forest uses MOTI to oversample the minority class. And you can see that in the end, our approach achieved satisfactory performance, showing that it's indeed possible to overcome the scalability issues of previous work and devise an approach to automatically perform this classification. So This led us to the question, now that we showed that the classification is indeed possible, how can this information be used? Developers perceive this information or review changes. To answer this question, we performed 12 semi-structured interviews with software developers, and we reports for 20 open source projects. In our semi-structured interviews, developers confirmed that indeed this information can increase their understanding of outcomes of the code review process. And they also pointed out towards tech leads and managers as the ideal target for this kind of information. Outcomes of the reports confirmed these previous findings coming from the interviews. So we obtained 17 answers coming from developers belonging to 10 open source projects. Developers indeed confirmed that this information provides a concrete way to measure the effect of code review. And they also acknowledge this information as valuable. However, they offered us also some ideas for future development of this of our approach and this kind of information. So for instance, they said that to fully make this information actionable, they would need to be able to interact with the data and to get further information on what kind of change belongs to each category. So to summarize, in this paper, we showed that it's indeed possible to devise an approach to automatically classify review changes, overcoming the scalability issues of previous work, that this information is indeed useful and valuable to measure the real outcomes of the code review process. And we also identified managers as a target for this information and for future development of this kind of investigation. So thank you for your attention.
Perfect timing as well, Enrico. Thank you very much for the interesting talk. And Diego, if you want to share your slides. So our next talk in the session is by Diego Costa, who will be talking to us about breaking type safety in Go, an empirical study on the use of the unsafe package. Go ahead, Diego.
Thank you so much, Sonia. I'll just also start the timer here real quick. So thank you everyone for joining. I'm delighted to present our work. It's done in collaboration with Suhaib Mujahid, Rabbi Abdelkarim, and Imad Shihab from Concordia University. And this work is about the Go programming language. So this language has been around for more than 10 years by now. It has very clean syntax, modern language features like garbage collector, and C-like performance. So it's very much the go-to language to implement systems like Kubernetes, Docker, because of the high performance. And one of the features of this language is strong and static type system. So in Go, even doing something simple as you want to sum an integer with a float, you cannot do this implicitly like you would do in Java, for instance. But if you do this, a compiler will complain to you saying, well, you're trying to mix and match like different types, like you need to convert them first, right? So things need to be explicit in the language to make sure that there's no type violation. So what does that mean is that Go is type safe, and that has a lot of good properties for software development. That means that if your code compiles, it has no type violation, there's no illegal memory accesses, all issues that are very expensive to fix in production. And if you find them in compile time, it's much better for you, except if you use the unsafe package. Yeah, so the unsafe package is this package provided by the language. It's a library of the language that offers a step around of the type safety of Go programs. So if you import that package, you can do pointer arithmetics like in C, like manipulate memory addresses. You can convert between types that may not even be compatible because compiler is not there to check for you. And in a way, I like to think the unsafe package is kind of the personification of the saying of Uncle Ben Spider-Man, like with great power comes great responsibility, right? So the package gives the power for developers to do low-level code manipulation, memory manipulation, more flexibility in casting different types. However, developers are on their own because compilers are not there to check the safety of the program. And there are risks of non-portability, there are risks of compatibility of future versions of Go, and it's very easy to write bad code. And you don't need to take my word for it. There's plenty of articles in the web saying the ones that are my favorites, avoid unsafe like the plague if you can help it, right? So because we know there's something developers are not supposed to use, we definitely know that someone is using this, right? So our work was motivated by this, and we wanted to investigate, do developers use break type safety in Go? Why do they do it for, and what are the consequences? And to that, we put on our mining hats, and we mine 2,600 projects, the most popular Go projects in GitHub, which includes Kubernetes, Moby project, InfluxDB, and so on. And to our surprise, actually a quarter of the projects use unsafe in their own code, right? And we even stratified that analysis per domain. And you can see here that while some domains use unsafe more often, like bindings, blockchain, machine learning libraries, all domains in our data set had some projects using unsafe. Right? So it's really widespread. So what do they use unsafe for? Why do they break type safety? So the first and most common reason is because of system integration. So they need to integrate with system calls and all the programs in C. And in this case, there's no way around of not using unsafe. So they have to break type safety for that. On the other hand, in 30% of the cases, they are actively trading performance for type safety. Right? Those are all cases that it could done in a type safe manner, but they did so because of performance. And there are, of course, some other cases that we described in the paper as well. So what are the consequences? The first one and the most surprising for us is that deployment restriction. So if you use unsafe, you may not be able to deploy your program in certain environments, certain cloud environments. Second is runtime errors, including cases of data corruption, and wrong API usage even cause security incidents. And the list goes on. We discuss a lot of it in the paper. Please take a look at it in more details. So we pushed the paper to archive and got a great feedback from the Go team, the maintainers of the language. And they were very surprised that people would use unsafe as much. And knowing that in our results, we justify spending more time and making it safer to use. And it has already had some impact in the Go language. So if you use Go 1.17, there are already new static analysis and language updates that were targeted in some of the shortcomings we presented in the paper, which we hope are making the language a bit safer to use. And that's it. That's the end of my talk. Thank you very much for your time. And please, if you have any questions, I'm glad to answer them.
Thank you very much, Diego. And we're going to move on to the next presentation. Ting Ting, can you share your screen, please? So our next presentation is B, and she's going to be talking about an empirical study of release note production and usage in practice. Ting Ting, please go ahead.
Yeah, can you see my screen fine?
Yes,
Okay.
and we can hear you. Yes.
Sure. Okay. Yeah. Hello, everyone. I'm Ting Ting. I'm going to present our work. So this work is a journal first paper, and this work was accepted by TSE 2021, collaborate with Xinxia and Zhuang Guangdi from Monash University, and David Lu from Singapore Management University, and Thomas Zimmerman from Microsoft Research. Yeah, so a release note as an essential that tells apart changes from the one version to another. Then we had 7 concerns about release note in the first place, that what information is documented in the release note, who documents it, and who is gonna use it. However, there was no systematically work around the release note. So based on these 7 key concerns, we defined our paper with 2 main research questions. The first one is trying to give a comprehensive understanding of release notes, including who is involved in release notes production and usage, and what information is included in the release notes. And second one is basically from developers' perspective, like what's the typical considerations they have of release notes, and what's any gaps between the producers and the users. Yeah, So to answer those two research questions, we conduct a descriptive study. We had 3 main stages. The first one is a large-scale empirical study on release notes. We defined 3 criteria to select the GitHub project, and 1,000 projects are included. And we finally collect over 32,000 release notes and other relevant information and of the select project. Yeah. So and the stage 2 is interviews. The purpose of the interview is to get some. Sorry. Just this. The second one is from this. Stage 2 is interviews. The purpose of the interviews was developers perceived the release notes, and we have 12 the interviews, and each of them it takes around 30 minutes. And the stage 3 is to invite the more developers to confirm the result of the stage 1 and the result of this requirement 1 and research question 1 and request 2. So comes to the results. To answer the question 1, in terms of who concerned, we found that there are many release notes producers and who document release notes, and there are usually main release producers who play the critical and more influential in the software development. And then regarding the what concerns, we summarized the 8 categories of development information, including the release notes, which is buying the whole development life cycle. We also found that information in the release notes for the major or the minor releases is significantly different. And to answer question 20.1.2, we summarized the 8 topics. For example, the topic 1 is about human and organizations factors involved for release notes production and usage. We also summarize a set of the statements about release notes that's relevant to many software activities. To answer the research question 2, we analyzed the collect data and found several significant gaps between the release note producer and the users. So release notes, for example, release notes producers are likely to focus on the non-functional requirements, and so based on the results of the requirement 1 and 2, we got a general guideline about release notes production and usage for developers to take away. For example, take the first rules as an example. Projects appear to have multiple people contribution to the release notes, and the main release notes producers are the key roles in development teams. So like collecting information from others, and also projects should carefully identify those key developers and understand how they work with each other. So finally, 2 directions of the works. So if you are interested in our work, please just go ahead and take our paper. So that's all for this work presentation. Thank you so much.
Thank you very much, Ting Ting. And we're going to move on to our next presentation, who is the presentation's actually going to be done in tandem. We're going to have 2 people presenting here. And Elgun, you can go ahead and share your slides. So our next presentation is bus factor in practice, and the 2 presenters are Elgun Jabrailzadeh and Mikhail Evtihiev. So please go ahead.
Hello everyone, my name is Elgun Jabrailzadeh. I'm a graduate student at Bilkent University. Together with Mikhail Evtihiev, we are going to present our paper titled Bus Factor in Practice. So in today's world, most software projects are developed by teams, and in team environments, there is a risk of projects to be get abandoned due to various reasons, one of them being a key developers leaving the project. Pass factor is basically a metric to describing this situation. It is the minimum number of developers that have to leave the project to stall. So we have observed various issues with using best factor in practice. First, is the best factor actually an important risk for software projects? And second, if it is important, it's unclear how to compute it correctly. So to address these issues, we have defined the following resource questions in our study. The first two resource questions are about the importance and relevance of best factor as a health metric to software projects. The third one is about the features that the best factor calculation algorithm include. And fourth one is about the accuracy of our tool developed for calculating best factor of projects. To answer these resource questions, we conducted a case study at JetBrains. Now, Mikhail is going to continue.
Hi, my name is Misha Evtikhiev. I'm from ICT at JetBrains Research. We did the surveys and the interviews to study whether the bus factor is a relevant issue and what properties the bus factor estimation algorithm should have according to the engineer. So let me start with the bus factor importance. From the interviews, we identified 7 most relevant collective development problems, and we asked our respondents to estimate how much these problems impact the workflow and how often they occur. Respondents perceive the bus factor as the most important collective development problem. Moreover, according to the survey responses, the bus factor is a tangible risk that is not checked often. So these findings bolster the idea that the bus factor is an important metric of a project's health. Let us move on to the relevance of various knowledge creation distribution modes. According to the respondents, commits and code reviews are the 2 most important modes. We chose commits, code reviews, and online meetings for our algorithm, and the survey results show that adding other modes, such as issues or code comments, may be helpful. So the respondents have different opinions on the bus factor algorithm details. They have different opinions on how fast the knowledge decays with time, or what should be the granularity for the bus factor calculation. These disagreements may be explained by differences in the content and structure of various projects. Thus, the user of a bus factor tracking tool should be able to tune the parameters. Reporting the bus factor metric, and especially the key engineers part of it, may backfire. Some of the concerns mentioned by the respondents are listed on the slide. It is interesting that the respondent concerns were less pronounced during the interviews. We believe this difference we observed means that the reasons to use the tool should be explained to the team. We also believe that the tool should be used on an opt-in basis per team, and the opt-in decision should involve the development team. Furthermore, we believe that our tool, or any tool, should never be perceived as an ultimate arbiter of the bus factor or any other health metric of a project. It should just be used as an additional source of information on the project. I'd also like to mention there were many more findings from surveys and interviews which didn't fit into this presentation, so I encourage you to read our paper. Now, Algon will continue with the bus factor algorithm and the validation survey.
So in this study, we also developed a new bus factor calculation algorithm by extending the baseline algorithm developed by Avelin et al. The algorithm was just using code commits as the contributions. We additionally integrated code reviews and meetings by mining this data from JetBrains Space platform. And additionally, we also integrated forgetting curve into the contributions. To validate the algorithm's performance, we have conducted an additional survey with JetBrains employees, asking them to list the best factor and key developers of the projects they have been working on. We got 14 respondents, and according to these responses, we use these responses as a ground truth, and according to that, we calculated the mean absolute errors of our algorithm and the baseline algorithm, and ours got a slightly better scores. So we can conclude that adding additional data can lead to a better calculation of best factor. So in conclusion, we conducted exploratory interviews and surveys to get practitioners' opinions on the best factor as a health metric. We derived practices to address the best factor issue and provided recommendations on the design of best factor algorithm. And we developed a multimodal best factor algorithm by integrating code reviews, meetings, and forgetting curve, in addition to the code commits, which got slightly better scores than the previous state of the art. That was it about our study. Thank you for listening.
Thank you so much to both of you. And now we're moving on to the last live presentation in the session. And the presentation will be by Fangwen Mu. You can go ahead and share your screen. And the title of his talk is Bug Listener, Identifying and Synthesizing Bug Reports from Collaborative Live Chats. Please go ahead.
Okay. Introduction. Hello everyone, I'm Fangwen Mu from Institute of Software, Chinese Academy of Sciences. Today my topic is Bug Listener, Identifying and Synthesizing Bug Reports from Collaborative Live Chats. As we all know, OSS developers are distributed across the world. They rarely meet in person. Instead, they coordinate most of their activities through online chatting, such as Slack, Gitter, and HipChat. Therefore, collaborative live chats are gaining popularity as a development communication tool. So what are they talking about in live chats? Our previous empirical study on 8 open source communities shows that 32% of the dialogues are reporting errors or bugs. Let's see a real example of developers reporting bugs in live chats. In this conversation, developer David reported a performance bug that Docker took a lot of disk space, and this bug is confirmed by other developers. Indeed, we can extract the bug description, observed behavior, expected behavior, and steps to reproduce in their conversation. Unfortunately, the nature of live chatting makes these bugs get quickly flooded by new incoming messages. After several months, some formal bug reports are submitted to the GitHub, reflecting the similar problem. So we can see that if the bug discussed in live chats could be identified timely, it may have been resolved earlier by the Docker community. So our goal is to automatically identify and synthesize bug reports from live chats. But how? To achieve that, we divide the problem into 3 subtasks. First is dialogue disentanglement. Given the historical chat log, we disentangle it into separate dialogues. Second is the bug report dialogue identification. Given a separate dialogue, we determine whether it reports bug. Third, given a predicted bug report dialogue, we extract the sentences about bug description, observed behavior, expected behavior, and step to reproduce respectively. Then we assemble these sentences into a bug report as our final output. This is an overview of our approach. It consists of 5 main steps. The main idea is we use a feed-forward network to disentangle dialogues, use a graph neural network to learn the contextual representation. To synthesize the bug reports, we use a BERT model that are pre-trained from external bug report dataset. To evaluate our approach, we design 3 experiments. First, we evaluate the performance in identifying bug reports. The results show that our approach outperforms other 7 baselines. Second, we evaluate the performance in synthesizing bug reports. The results show that our approach achieves the best performance in extracting OB, EB, and SRS sentences. Third, we evaluate the effects of main components. Results show that all the main components are helpful for our tasks. We also conduct a human evaluation. The results further confirm the effectiveness of our approach in generating relevant and accurate bug reports. In summary, we propose Bug Listener, including a deep graph-based network to effectively identify the bug report dialogues, and a transformer learning network to extensively synthesize bug reports. Second, the evaluation results show that our approach outperforms existing methods. This demonstrates that applying Bug Listener in community-based software development has the potential of promoting bug discovery and quality improvement. That's all of my presentation. Thank you.
Thank you very much, Fangwen. So this completes the talk part of our session. And now we're opening things up for questions. And feel free to type your questions in the chat or to unmute yourselves and ask the speakers a question directly. So we have a question already for Diego in the chat, and that's from another one of our speakers, that's Mijail. So I don't know, Mijail, if you want to just ask Diego the question yourself.
Yeah, sure. So the question is, you mentioned there are different cases for using unsafe. I want to be able to reproduce, I'm sorry. And for some of the cases, there are no ways around. Whereas in the other cases, it's simply to improve performance, something like that. So one can do it without unsafe. Is there any difference between these two groups impact, such as bugs, incompatibility?
Yeah, thank you, Mikhail. It's a great question. So I have two answers. The first and more scientific accurate, that we don't know, because the link between the usages and the issues are not straightforward. So projects have multiple use cases and they report some issues. However, we found two types of issues that mainly happened when developers were using unsafe for better performance. So they're misusing the API for when they're converting between different types. And we found this, and the other case was found even by the Go team, in which the new static analyzers that they implemented are meant to capture those cases. And we even found that developers copy and they copy code from project to project. So if we would Google or actually do a search on GitHub about the pattern that was wrong, you'd find thousands of projects doing type conversion in a row. So what happens is that sometimes it would work, but there are a chance the garbage collector can collect and swap the memory in the middle of the operation. So it's a non-deterministic type of error, and very difficult to find. So like I said, now for us to infer whether one type is more bug prone than others, it would need to go more in depth. But like I said, some types of errors are related more to the performance side. And my experience of the project would say that when they use for integration, they try to do more consciously and more constrained than when they are doing for performance optimizations, because they have to go and dust the bytes in a way for performance, and that can be more difficult to do. Yes. Thank you for the question.
Thank you. Thank you very much.
Maxime, do you want to go ahead and ask your question to Enrico?
Sure. Yeah, I can ask it. So this is kind of thinking of like Goodhart's law in mind of like a metric ceases to be a good metric when it becomes a target, right? So now that you have this tool, which is wonderful, by the way, and managers seem to be the most interested with these results, this information. Now that they can get measured effects from code review, do they just want it to like get a pulse of the project, to get a feeling of how the project is going, and it's just a informal information, or do they seem to want to use it as a kind of performance metric? I'm just worried that by getting this information, they may start to seek it as a performance metric, and then it'll bias future reviews, and then they'll become useless basically. Do you get that feeling, or do you get the feeling like it's more just getting a feel for things?
So thanks a lot for the question. So in our interviews, we interviewed like a vast number of developers, some of them at more manager, they were more close to managers in a way, some were just software developers in a way. So to fully understand what managers and tech leads want, I believe that we should conduct further studies to target the specific audience. So from our investigation, we understood they are the audience we want to target. And in a future investigation, we should really understand what now this audience wants from this kind of information. However, what I can say is this the topic of the question you just asked. So is possible that this kind of information becomes a metric that managers can use to evaluate developers, or that developers can use to maybe compete with each other, emerged actually during one interview where we were trying to understand exactly this. So how can we apply then this information? How can we display it? So some of the participants had this exact concern, and this is definitely something we don't want. We don't want our metric to be, this kind of information to be used as an evaluation metrics. Also because it can become problematic. I mean, if I am a developer who can find a lot of structural problems in the code, am I less important in a way? Do I perform worse than a developer who's able to find functional defects? So what some of our participants proposed instead was to create some kind of benchmarks. So to compare the results, for instance, of the single developer against an average developer, and then try to understand who should see this information. Should the manager be able to see this? Should the developer be able to see this? Or even better, to create a benchmark based on the old project in the past or similar projects to make managers understand, okay, my old team is performing similarly to how they were performing 3 months ago. This could be interesting, for instance, if they change something in the pipeline, if they introduce a new tool, to see, okay, the new tool is having this kind of effect compared to 3 months ago where the tool was not in place.
Right. Thank you. Very interesting. Thank you very much.
And you are still next, Maxim, in terms of order of questions. So go ahead and ask Elgun and Mihail.
Sure. I'm not sure which of you will want. So it's a two-part question. I guess either of you can answer, or both of you can answer both. So the first part was, I noticed there was you made it obvious that there was a huge mismatch between like the measured bus factor that you managed to measure and what the devs said that they knew there was a bus factor in their project, right? And did you get a feeling like that was just they didn't realize that there was this potential bus factor in their project, or someone knew that they were like super important and that they were the only one working on a project and that they might leave, but they just were not communicating that information?
So yes, thanks for the question. I think I can answer this one. So actually, I think there is a little bit of misunderstanding. Sorry for that in our methodology. So we conducted the surveys to get the actual bus factor numbers of the projects. So according to the responses of the survey, we used it as a ground truth. So in our study, we assumed that the software engineers knew the bus factor of the projects they have been working on. So using this ground truth, we validated our created algorithm. So the mismatch here can show that the algorithm was not efficient enough to predict the actual bus factor of the projects.
Okay. And for the second part, do you think it would be better if we gave a warning, like if we calculated a certain threshold value where above a certain threshold value, we give a warning to the team, like, hey, by the way, you have a huge bus factor, be careful, maybe you want to communicate more internally, you don't like reduce the number of silos in your team? Or did the devs actually want the information out in the open as much as possible, and having a threshold would actually hide this information, so they'd prefer just having it out there and whatever comes?
So I'd say there is no silver bullet, no one-size-fits-all solution here at all. There are like for many questions we asked about the bus factors, there were completely contradictory responses. Like some people would like to have as much information on the bus factor as they could. Other people are very uncomfortable with this information being shared. Yet some people would told us that we heard this I heard this in a couple of interviews, that they're afraid somebody could leverage that. Say there is one person who is the key. When they learn this and they have some data to approve, they come to the manager and they start haggling for salary. So this is why we focus on one has to talk with a team, one has to explain this is just a metric. It's not an absolute truth. It's just like an indicator that something is right or wrong. And I believe that if one talks to the team, if one explains that, okay, there is this way to track the situation in the team, and it's giving us some kind of insight, and it's easier to like have one agreement of manually expecting lots of files, and then we may be able to do something about it and discuss. This would be a right approach. While if it's at any point somebody says, okay, there is this list of key engineers which are very important persons and the rest of them which are not very important persons, I would say by this moment we already lose, because at this point there is like a ladder and unhealthy competition and so on. So I would strongly, the question, you asked a really good question, really one-on-point question, but the trick is we would really like to avoid people saying that somebody is important enough or not important enough. This would be very much against our design.
Yeah, so better to use it as an indicator of something going wrong and just say, this is an indication, it's not proof, it's just be careful.
Yeah, so there was actually another presentation at ICSIA, I just can't recall the name of the presentation, where they suggested some data about the project, not project level, but on the file level and the method level, such as like file ownership and stuff like that. And they presented this stuff like a set of like thermometers or indicators of scale in which you should be, and indications that say, okay, here the ownership is too high, so maybe we want to just a few developers focus on stuff. I believe one should proceed with the buzz factor in a similar fashion. So you should have some important health metrics, and buzz factor is a really important one. And so you look at that, you look at this, and you know that these things are going good, and the others are not so good. That would be my take.
Excellent. Thank you for your answer.
Thank you.
Thank you. Are there any questions from the audience? You can unmute yourself and ask a question. Okay, well, we're waiting for people to formulate their questions. I have a question for you, Maxim. Now, it's your time to answer and instead of asking questions. So my question for you was, so if I understand correctly right now, the patterns that you discovered were pretty much based on manual kind of observation. Is that correct? So I was wondering if you've thought of like any maybe automatically be able to identify such patterns. And one thing that came to my mind was maybe like code clone detection tools, where you can find similar code that basically does maybe functionally they might be the same, but it's written somewhat differently. And if you think that that would be a viable way to expand this and to automate this process and to add additional examples.
Yeah, so that's a really good question, actually. So right now, the patterns that we found, so I think part of it is code clones can be definitely used to find patterns. So to answer your question, I think definitely the answer is yes, code clones can be used to find these patterns. But I think that the low-hanging fruit, the ones that are easy to find using code clone approaches or that people can think of generally, those are the ones that are already part of most of these static detection approaches. So those have been found, those can be detected using basically like code clone detection approaches. And internally, we basically, the way that static detection approaches work is we detect common patterns based on a sea of examples. We then use static analysis to determine, does your code resemble this or not? So it kind of is actually code clone detection in the first place. And so the fancy part is, well, how difficult are your clones to recognize as clones, right? And when are they not actually clones? When are they like close, but they're missing a part? And then that's when you have a misuse. So the examples that we found in most cases, I would say, are almost like, if you're familiar with clone terminology, like type 4 clones. They're semantically equivalent, but actually like what's the way that they're written is different. So they come out to the same at the end. So that's where we find our patterns, and then we create a tool that actually can automatically create these examples based on our patterns. Finding more patterns is a bit difficult, but I think it's just a labor-intensive process. Like, you can use code clone detection approaches to help you. You can use kind of clustering algorithms to try and cluster code to come up with things that look similar. And then at some point right now, someone has to make the call at the end of the day of, can we make a transformation pattern for this? Maybe in a few years, everything is going so quickly with machine learning. Maybe we can have some approaches that will automatically transform code, but we're not there yet.
Thank you. Diego, you want to ask your question?
Yes. So the question goes to Mikhail, which I just realized there's a type in your name there. Sorry about that. So we have been sort of seeing bus factor being calculated and used in the context of open source projects. And they tend to be very much focused on the source code analysis, commit analysis, and so on. So based on the survey, if I were to take the work and say, okay, I want to have a more comprehensive bus factor calculation for open source, what kind of sources do I need to look for? Do I need to look for issues that requires maybe a channel of communication of the project? What can you tell me about that?
So my take is as follows. So you would use as many sources as possible. So key is, well, commits is obviously available. You would really like to have a look at code reviews. Now, this is tricky because not everyone uses code reviews at GitHub, and then I'm not sure if they're easily accessible. But some cases people use other systems, so this is also an option. And then, Ilgun, if I could please ask you to share the presentation. We had this list on the slide, and we also had this list on the paper. So things that might be accessible, code comments, I think, and issues should be also available from GitHub. And thank you so much. Should be accessible issues. Project documentation should be also, it depends on how is it written, but then sometimes you also have data on who wrote the project documentation. If you can gather that, you can do well. So I'd say it's an incremental improvement. Every time you add some more modes, you're able to capture some more data. And in any case, you'll probably miss something because there will be a project manager who only goes to meeting every once in a while, but then they read the code so much they're actually an expert on the project, but it's impossible to capture. But I think that basically you should, if I would be giving recommendations, I would say that you should start with comments. You should really try to add code reviews if you can, and then you can add one by one from our laundry list. And it seems that many of the things are kind of on par. So should probably
Thank you.
go with things that are available.
I'll take a look at the table too then. Thank you.
Thank you.
Okay, I have a question for Tinting. One of the outcomes, right, of the study was the fact that one of the findings was the fact that there is a discrepancy between the users and producers of release notes, right? And the question that I had is, do you have any idea on why, like, what would be the major source of that discrepancy? Why is there why is this discrepancy present? Do you have any idea of why?
Basically, our work is based on the developers. So we just investigate the developer from GitHub, and the users and the producers are most of them are developers. So I asked them why they care about the users. Basically told us it's like most of information is around the bug reporting, and we fix this bug, fix that bug, but it's not that informative for them to do the testing. Another works. So, but for the another producers, they are saying this way is probably the faster way to do. They just collect some data, just relevant to the bug, then put the release note. But they probably, I would assume they probably saving some time to do the release notes. But for the users, it's not that formative. I think that's the biggest gap between them. So we summarize the guideline to how to fix this problem, and we hope they could work. Yeah. So basically, it's run issues.
And what would be one of those? How do you think we could fix this issue?
So we recommend them to just several general suggestions, maybe some writing styles, and then also keep in mind those like easy ways is not the best way, not the effective. Our document release notes or some other documentation. So also another thing is like to use some tool, maybe bug report and other requirements and some other informations. You can use this tool to organize the information into documentation. Yeah, some general suggestions. Thank you.
Got it. Thank you very much. Yeah. And I have a question for Fang Wen. So, but actually, let me check. Is there any other questions from the audience? I don't want to take off all the questions. Okay, so Fang Wen, my question was for the first part of your evaluation where you compared with other approaches, right? I assume that so the evaluation was done on how well they can identify the information to include in a bug report. Did I understand that correctly? Or if not, can you explain a little bit more?
Yes, the first research question of our experiment is to evaluate the performance in identify the bug reports, the bug reports dialog.
Great, and I was wondering, how did you get the ground truth for that? So how do you know what's correct there?
Yes. Since we first collect our data from the data platforms. We use the REST API to crawl the data and manually label the data with two labels: the bug report dialogues or non-bug report dialog.
Got it. So basically, you had to do that manually, and was that like I guess it was pretty labor intensive?
Yes.
Like you had. Okay, and do you think that there's a way to automate that in the future somehow, to get that data without manual effort or with less manual effort?
Yes, we try to automate. Since the chat log is entangled in the live chats, so we first use the feed-forward network to automate disentangle the chat logs into separate dialogues. But the label of the bug report dialogues, we need to manually label it.
Thank you. Are there any other questions from the audience or any of the speakers? If not, I think we can wrap up this session because we're right there at the end. So I would like to take a moment to thank again all of our speakers. Great job, everybody. Your timing was perfect. Your presentations were really nice. Really, really great job. And it was a pleasure to meet you all. And I hope I'll see you in some other sessions at ICSI.
Thank you for sharing.
Thank you. Thank you, Sonia. Great sharing.
Bye, everybody.
Thank you. Bye.
Bye-bye.